Welcome everyone. Today we're going to be looking at geometric sequences and series. So to begin with, let's talk about the geometric sequence itself. So if I have a given sequence, like the one below, 1/2, 2, 8, 32, so on and so forth, the big difference between arithmetic and geometric is instead of addition, where we're taking a constant value and adding it to each term, between any two given terms, we're now going to be multiplying. So 1/2 to 2, I would have to multiply by 4, 2 to 8, multiplying by 4, and 8 to 32, I would be multiplying by 4. And this value that we're multiplying by each time is called the common ratio. And it's a common ratio because if I take any two successive terms, let's say 32 and 8, the ratio between them will be that value. So kind of like dividing in reverse. So I can do the same sort of thing to figure out the general expression, which is to write it out vertically, similar to the arithmetic sequence. So if I do that, I can see that a1 is equal to 1/2, a2 is equal to 1/2 times 4, a sub 3 is going to be equal to 1/2 times 4 squared. So now instead of adding the common difference 2 times, I'm multiplying by the common ratio 2 times, and so that would get me to 8. A sub 4 then is 1/2 times 4 cubed, which is equal to 16. And the pattern will continue in this way. So I think we can kind of see the basic structure, which is that we're going to have our first term, which is 1/2, times the common ratio. And then again, I can look at, for each given term, the number of times I multiply by the common ratio is 1 less than that term. So if it's a sub 2, then it's going to be 1 time. A sub 3, I'm going to multiply by 4 2 times, and a sub 4, I'm going to multiply 3 times. So in general then, for a sub n, it's going to equal 1/2 times 4 to the n minus 1. And there's no real way that we have to necessarily rewrite it like we do with the arithmetic sequence. So that would be our general expression for our geometric sequence. So going back to our notes then, up at the top we just have some given sequences, so I'll zoom in a little bit to them, and we can kind of test out and see, alright, so do these have common ratios or common differences? So if I look at the first sequence, it looks like if I take -12 over 3, I get 4. If I take -48 over 12, I also get 4. And I'll get the same with -144 and -48. So we can clearly see that each time we're multiplying by 4. So then a sub n is going to be -3 times 4 to the n minus 1. And this is clearly geometric. Second example, a little bit trickier. So I've got 1/2, 1/3, 2/9, 4/27. So I could look at my common ratios again. So if we take 1/3 over 1/2, multiplying by the reciprocal, we'll get 2/3. So let's take a look at 2/9 and 1/3. So 2/9 over 1/3 is also going to be 2/3. And if I took 4 over 27 over 2 over 9, I still get 2/3. So my common ratio here then is going to be 2/3. And so note a sub n is going to be 1/2 times 2/3 to the n minus 1. Now we can maybe get rid of this, save a little space here. And this is definitely geometric. Okay, so what about C? So if I look at C, I can see that 10 over 6 is not equal to 15 over 10. Because 10 over 6 would be 5 over 3, and 15 over 10 would be 3 over 2. So it's definitely not geometric. Now, which type of sequence would it be, though? Would it be arithmetic? Would it be quadratic? Would it be something else? I'll let you ponder that. And for D, we can clearly see that D is adding by 1.3 each time. So this is not geometric and is in fact arithmetic. Okay. So if we look at our sequences, it should be pretty simple to determine between arithmetic and geometric. C, if you look a little bit closer, you'll find is a quadratic sequence. So in the middle section of the notes there, it wants you to define the geometric sequence and think about how you contrast the two types. I'll let you put that in your own words so that it makes a little bit more sense for you and allows you to clarify in your own words what the differences are between them. So if we go down then, if we go down to the general term of the geometric sequence, again, we can write our general expression as the first term, a sub 1, times our common ratio to the n minus 1 power. So that's going to be our general form for the geometric sequence. But similar to the arithmetic, we don't have to have the first term. So we could have a sub n equals a sub 3 times the common ratio, but then it would be to the n minus 3 instead of n minus 1. So we'll put that as an or. And even more generally, for any two terms that are positive integer values, so n and m again, a sub n is equal to a sub m times the common ratio to the n minus m power. Okay, so again, just a separate form that may be useful if we don't have the first term given. So we'll look at the first example here then on the bottom, which is find the 15th term of the geometric sequence. 300, 150, 75. And it says represented as a fraction because clearly if we're taking the 15th term, we're going to have some really small numbers here as our sequence is decreasing in size. And I think we can clearly see a sub 1. So a sub 1 is 300. And our common ratio is pretty easy to see as well. If I take any ratio of successive terms, I'm going to get 1/2. Oops. And so a sub 15 is going to equal 300 times 1/2 to the 15 minus 1 power. So that's going to give us 300 times 1/2 to the 14th. Now that's going to be really small. So if we wanted to, we could simply write it as 300 over 2 to the 14th. And you can put that in your calculators to get a verification of what that fraction would be, or you could divide it yourself. All right, so that's going to conclude the first part of our notes then, just discussing the geometric sequence. So we're going to look at some other examples of geometric sequences and then get into the series of adding up the terms of the geometric sequence.